think we have just about everybody. So thank you guys all for coming. Thank you customers and JMI company alike. This is Andrew from JMI TV, and welcome to this week's episode. So today we have Carl Lang, Regional Manager from Thermon, with us here today. And with more than 20 years of experience, I'd say Carl has seen probably just about everything. And we're very excited to share our new heat trace controller today, which has a lot of modern features that, frankly, I think every process instrument should have. What sets this controller apart in my mind is just how easy it is to use. Whenever I'm evaluating a new product, I'm often asking myself, why didn't they put this feature or that new feature in the product? Why didn't they make it more easy to use? And this is the first product where I actually didn't have that comment. They did such a good job that I was left rather speechless as to what improvements I thought it should have. So Carl's going to expand on everything that the Genesis controller can provide in under 15 minutes. And without further ado, we have Carl Lang with the presentation. Go ahead, Carl.
Thank you, Andrew. Again, my name is Carl Lang. I'm the Regional Manager for Thermon, and what I wanted to go through today is our newest heat trace multi-point controller. It's our Genesis controller, and we believe it to be the most advanced heat trace controller on the market today. One of the nice things that we have, and we'll talk about all the different components, that it is a modular design, but the human machine interface is has the capability of doing up to 72 circuits, and each one of those circuits has the capability of sharing or assigning up to 20 RTDs per circuit. Also, our panels are rated to an IP66 or a NEMA 4X rating, and I'll go over the whole entire construction of the panel here in the next slide. Missed this slide. We also have communication capabilities of Ethernet, Modbus, TCP. Again, it's a waterproof HMI. The HMI itself is rated to IP67, and the temperature range for the controller itself is negative 40 degrees Fahrenheit to 140 degrees Fahrenheit for the panel, and up to 158 degrees for the HMI itself. The Genesis controller, what we've done is we've taken a multi-point controller, we've actually put it into a modular configuration. There's basically, the nice thing about this controller, it's basically made up of 4 basic components. The first one being the HMI, and we'll get into further details later on in the presentation. But you have the HMI, the human machine interface, which allows us to do configuration as well as look at a number of different parameters within the heat tracing control circuits. We have the DCM, it's shown on the left. The DCM is our distributed control module. All these boards on here are smart boards. All the intelligence is embedded within the distributive control module. So what that means is that any of these modules, they work on a CAN bus network, and I'll talk about that in a second. They communicate to the HMI, but for some reason, if the HMI gets damaged, you do not lose control of your circuits, because each one of these boards that I go through are intelligent boards, so all the intelligence resides on the board level. The DCM, it'll actually do all the communication to not only the DTM, which is the distributive control module that you'll see on the bottom right hand of your screen. That distributive control module will handle up to 6 RTDs per modules, and we can daisy chain a number of modules via a 24-volt CAN bus network. So we can go up to several of these boards, so we can go up again, assign or share up to 20 RTDs per circuit, up to a total capacity of 72 circuits per panel. The other device that you'll see kind of in the bottom middle is the IOM module. It's the input module, output module. What it allows us to do is gives us physical contact relays for global alarms, low temperature alarms, high temperature alarms, and so forth. It also has the capability of taking digital inputs that allow us to maybe force a circuit on or turn on the panel via control from another control system through a discrete input. Again, the Genesis panel is a modular panel, so we have our 4 basic modules. Again, the DCM can handle up to 6 circuits. The DTM can handle up to 6 RTDs. The IOM has 7 output or input modules. The nice thing about all these modules are that they are rated for hazardous area, which is a class 1 division 2, groups A, B, C, and D, T4. The actual panel operating range is a -40 to 140 degrees Fahrenheit. We have in this, all these components are very safe. We know that the safety is a higher priority within our customers, and everything that you see runs on a 24-volt, 4-wire system. So it's a CAN bus communication system. We know that's a very robust system. It's basically was developed for cars in the automotive industry. So we know that it's well tested and very robust. The other thing that we have at the bottom is everything that we use within our panel is just standard Phoenix connectors. So there's no special tools required to do any kind of maintenance, upgrades, or expandability within our control modules, or our control panel, I should say. You only need a standard screwdriver, a tweaker, and wire strippers. That's the only 3 tools that you'll need to do any kind of expanding or maintenance within the Genesis control panel. Again, one of the nice things about the HMI, it's a fully sealed product. It's very easy to replace if something did go wrong with the HMI. It essentially has 4 screws, which allows for mounting in the panel, and 3 quick disconnects in the back for your power, your CAN bus network, and USB port and Ethernet ports for communication. Display, we have multiple layers of display and multiple displays to provide a bunch of information for each of your heat trace circuits and also the overall health of your heat tracing system. The display mode can be shown in either a day or nighttime. So you can, whatever your preferences, you can have it display either in the daylight or the nighttime mode. One of the nice things that we say, we have a upgraded, or we made this in an industrial strength HMI. Again, it has a temperature rating from a -40 to 158 degrees Fahrenheit. The screen itself is a capacitance glove touch screen, so you can actually touch the screen or use the screen in cold weather by using a glove. But we also upgraded the actual capacitance touch screen itself. A normal touch screen, capacitance touch screen, has air voids between the capacitance layers. We've upgraded that by filling those air voids with a silicon gel. That provides 2 bits of advantage that we have within our HMI display. One being that the gel in between the capacitance layers actually disperses the light, so it doesn't allow glare off the screen. So even in intense bright sunlight, you can read the screen. It also, between those capacitance layers, we don't have to worry about fogging and moisture getting in and damaging our display because we have silicon gel in between the capacitance layers instead of air. Again, we get multiple screens within the HMI that gives you a lot of different information. The first screen, we do have an overview screen, and as you've seen it, we try to make it simple and intuitive such that you can get a quick assessment of your heat tracing system and the health of your heat tracing system. If you look at the display, you'll have multiple dots. Those dots represents an individual circuit. If they are green, they're on. If they're gray, they'll be disabled. If it's red, it's an alarm. We also give you a lot of information on a per circuit basis. As you notice, we give a graphical display. You have a blue band, which is cold or low temperature. Green is good. Yellow is alarm. Red is high alarm or high trip. We tell you what the set point is. We show you what the actual temperature measurement is. We have a very descriptive tag name. We can get up to 50 characters. And we also tell you if the circuit is on or off, or what duty cycle is at. In this particular case, it's showing 100%, but that could be 52% or 57%, whatever the duty cycle is of that particular circuit. If you want more details on a per circuit basis, we have a detail screen, and within that screen, we can actually, at the top, you'll see again the tag name. You can also disable, enable, force on, or force off by quickly and easily touching the button on the very top. We also display the 3 main parameters for your heat tracing circuits: temperature, current, and ground current. We also display the operation of each one of those circuits in a graphical representation, as well as show you the actual parameters or set points for each one of the circuits, such as low alarm, maintain temperature, high alarm, and etc. As far as the programming of this, it's very intuitive. It's very easy to do. If I was to want to change the maintain temperature in this particular slide, if you touch the square where it says 220 degrees maintain temperature, if I touch that, it'll pop up a window. I can simply adjust that. Let's say I wanted to change that to 225 degrees Fahrenheit. I'd type in 225 degrees, hit enter, and you would change the maintain temperature or any of the parameters that you see on the screen. So it's very easy, very intuitive, and essentially there's no training required. The next screen, again, we're giving you multiple screens of information. We have a screen on a per circuit basis that we can show trending of a day, a week, a month, 3 months, or 6 months. It'll show temperature versus current. So this gives a very good diagnostic tool of troubleshooting or looking at the health of any individual circuit within our heat tracing system. We also have the ability to put all the engineering deliverables on a per circuit basis for each on the screen for someone to view. And it's not just a single picture. We can put multiple documents in there. So for example, on a heat trace circuit, we can have the heat tracing isometric, we can have the panel board schedule, we can have the power plot plan, and we can have the P&IDs. So with those 4 documents, we basically know every bit of information that we would need to maintain or troubleshoot a heat tracing circuit. This circuit works, or this screen on a per circuit basis works just like your iPad or your smartphone. You can pinch it or to zoom or move just like you operate your smartphones. We also have the capability of having another screen which you can get circuit notes. So what we can do, this is a free-form text. For each one of the circuits, we can add notes. In this particular case, we could put in notes when we calibrated, put notes for troubleshooting. We can also put notes in there such that if you have a single circuit that is a freeze protection circuit that is controlling the freeze protection for multiple instrument tags. Sometimes those tag names can be quite long, so we couldn't fit 50 of or 5 of them in that 50 characters. So what we can do is put a note on there, C notes, and we can list all the instrument tags within the note section. We also have an interactive displays as far as the circuit alarm view. So in this particular thing, we can easily touch the front screen. We can see our circuit list, or circuit alarm list, I should say, and we can look at all the alarms per circuit. We can also look at those by alarm types because we can prioritize our alarms. If we want to see ground fault or low temperature alarms, if we were looking at the hierarchy of alarms, those would be typically the first and second. So we can look at them instead of looking at all the alarms, we can prioritize them, or we can assign certain process tags. So if we want to look at a certain process tag or a certain area on those alarms and check that easily and quickly, we can basically look at those alarms associated with those process tags. As far as configuring and the configuration or setting up the Genesis controller, we can do that via a software program, which is free and available on our website, but you can simply import or export the configuration, the program files from the Genesis via the USB port in the controller itself. So something instead of would take you a number of minutes to configure multiple circuits, we can do that within under a minute. We also have the capability of building our controls, not only just the control panel, but we can integrate that on a switch rack with, in this particular case, you'll see integrated with Class 1 Division 2 sealed breakers. So we can put together an entire assembly, switch rack assembly. In that case, it is a lot more cost effective in the field because we can put not only the power distribution and the control panel, we can also pre-wire a transformer. We can ship this control rack out in the field. So you drop in place, all you basically have to do is bring in your primary feed to the primary side of the transformer and then wire out your power connections, wiring from the controller to your power connection. So it's very efficient and a cost savings for installed cost into the field. We also can do this. Not only can we have the power distribution externally, we can also mount the power distribution internally within the control panel. This allows us to save space if you're in a space constraints, maybe an MCC or in a operating unit. This is kind of show you some of the interface. On the picture I showed you before was just showing the electric board, but the nice thing for our DCM6 control module, again, these control modules has all the intelligence built on board, so it has all the algorithms to do your on-off or proportional control or what have you. This allows us to, this board allows us to turn on and off the circuits, and it's very well laid out as far as from a maintenance standpoint. As you see, you'll have your solid state relays, which are easily accessible, and also all your terminations are done on standard UT10 Phoenix connectors, which you just use a standard screwdriver to do your wiring. And it also gives you the capability, because that UT10 will do up the number 6 gauge wire. We've left some room if you have a larger wire size due to voltage drop. We can easily accommodate that by just snapping on the larger size Phoenix connector. Again, I talked about this briefly. We do have a software programming which we can download and upload all the heat trace system configurations. So it's very easy to do. You can do it on a laptop. You can keep a record for that. Then you can simply make any changes to the controller and simply upload those into the field. Our control panels are smart control panels. We can set it up such that we can network all these controllers on a digital communication highway, and you can look and interrogate and do any kind of configuration settings remotely via a laptop. And we can expand that within our Genesis network. Basically, that gives us the capability of not only doing it on a hardwired, like an Ethernet or an RS-45 serial communication, but we can also use that on a wireless mesh network where we can not only wirelessly transmit all the information between our controllers, but we also have the capability of installing wireless RTDs in the field, which will communicate back to our controllers, which will save projects in conduit and wire. I believe that's my 15 minutes, and I'd like to open it up for any questions that anybody may have at this time.
Thank you so much, Carl, for presenting. That was a great presentation. I am going to, oh, just hang on one second. Okay. I am going to allow everybody to talk. So I'm going to unmute you guys to the chat. And we're going to start off with a couple of questions. I'm going to start with the first one. It's going to be on your screen. Go ahead and vote. So the first question, how many circuits give you access? All right, so 72. Carl, I think you're right. Are we right?
That is correct, 72.
72, all right. Let's go on to the next. Oh, I guess Carl stopped. Hi, everybody. Carl stopped showing the presentation. That's all right. Next question for everybody. Can documents be stored on the Genesis controller? I think people were paying attention. Or maybe I made the poll questions really easy. But I've got quite a few votes coming in. Yes, they can. And as Carl mentioned, it's not just the ISOs. Everything you need can be stored on the controller for every circuit. So, and then final poll, and then we're going to open it up to Q&A. Any questions anybody has can answer in a moment. Final question, is this the easiest or the best user interface you've seen out of heat trace controllers? I'd love to hear your feedback on this. I think this product is extremely simple and easy to use. And I'd love to hear how you guys feel about it, a bit about it. All right. Thank you, guys. I'm seeing some 5 stars, and at this point, we'd love to hear from you. Does anybody have any questions for myself and for Carl? Oh, I got a few people that are, we're still working on giving them mic permission, or they're still connecting to the mic. So, but I think we pretty much covered everything. Carl, in terms of the basics, was there anything in the presentation that you might have wanted to mention that we maybe didn't have time for in the 15 minutes?
No, I think I covered generally most of the basics.
Mm-hmm. Okay. Well, thank you guys very much for coming. It doesn't seem like anybody has any more questions, but we hope that we answered everything you had. You have our email. Mine is andrew@jmicompany.com. Carl's is carllang@thermon.com. Feel free to reach out to us if you have any further questions. Thanks for coming, and enjoy your Friday. Enjoy your lunch. We'll see you all later.
Well, thank you, everybody, and be safe.